So today we're going to be looking at what an index is. Singular word index, plural word indices. All right, so if you see indices, you know that that's the plural for index. All right, so we have index being singular. Now we're in math class, but we still need a little English. So that's index, I-N-D-I-X, and the plural indices, I-N-D-I-C-E-S. All right, and all an index is, it's just a small floating number, usually projected at the top right-hand corner of a variable or a number. All right, so it's just a small floating number. All right, projected at the top right-hand corner of a variable or a number. All right, now, some of us are probably accustomed to 2 squared, 4 squared, or something squared. All right, so for example, we have, all right, we're just gonna go with 4 squared. All right, so this small floating number can be a variable too, but at this level, just gonna be focusing on numbers. But it's just that small floating number at the top right-hand corner of a number or variable. All right, could be, say, for example, a cube or a. All right, and what an index is really indicating is the number of times you're multiplying a value by itself. All right, so it indicates the number of times you multiply a value by itself. All right, the number of times a value or variable, remember variable is multiplied. Could be a combination of both, can be 3x or so on. All right, is multiplied by itself. All right, and for some persons, they want to know the use of indices. The use of indices is really for when a value is growing exponentially or really quickly. Can be growing very slowly as well. For example, the coronavirus cases. All right, so say for example, we have 3 to the power of 0, so that's one person. And one person can give that virus to 3 persons. So that's 3 to the power of 1. And each of those individuals would have given the virus to 3 more persons. All right, so we have 3, 3, 3. All right, and that's going to be 3 to the third power, for example. All right, so the number of persons that the virus can actually reach is growing very quickly. And so that's when we use exponents. All right, you use it to represent when values are growing really quickly. So it has its place in science and in other fields as well. All right, so we just want to quickly look at that. All right, so it indicates the number of times a value or variable is multiplied by itself. For example, we did look at 4 squared. Let me get a different color. So all 4 squared is saying 4 times 4. That's it. So that 2 represents the number of times I will see 4 while multiplying. All right, and 4 is known as the base. This is the base. All right, that's the value being multiplied, but the exponent indicates the number of times you multiply the base. All right, another word for index, you might say power or exponent. All right, so another word for index might be power or exponent. So if you see power or exponent, still talking about the index. I don't know any other names for the base except base. All right, so if we look at a cubed now, you're supposed to have an idea. All right, a being the base again. That a is now being raised to the third power. And so we have 1a times a times a. And in case you're wondering, do we ever divide? No. it's always multiplying. All right, so it's number of times it's multiplied by itself. All right, so we want to look at how we read indices. What if you see raised to you see the exponent being 5 or 6 or 7? How do I read it? All right, so we're going to look at reading the index or the index along with the base. How do we read it? Then we look at the different representations, and that will be it for today. All right, so take for example, so I'm at objective number 2. Take for example, I have some value a raised to the 5th power. Well, I just said it. So this is going to be a raised to the power of 5. So if I need to communicate what I'm looking at or what I wrote down, that's how I would say it. A raised to the power of 5. All right, to the power of 5. Sorry about that. A raised to the power of 5. All right, let's look at another example. Say, for example, we have 2, 2. All right, the exponent being 2, the base being 2. So you can still write it the same way, just gonna change the base as well as the exponent. So you can just have 2 raised to the power of 2. So 2 raised to the power of 2. However, this is a special case. All right, so when you say 2, you can also say squared. So you could just summarize this and say 2 squared. All right, so instead of saying raised to the power of, you could just simply say 2 squared. 2 being the base and the squared representing the exponent. All right, so you could just say 2 squared. All right, let's look at one more special case. And that's, for example, 4, 3. All right, 3 being the exponent, 4 being the base. So you can take a minute to guess what we would say or pause the video to read that one just in the regular form that you know about. All right. So that's 4 raised to the power of 3. By the way, there's one more presentation. If you see it, it's the same thing. All right. It could be a raised to the 5th power. A raised to the 5th power. All right, same thing. Could say 4 raised to the 3rd power. All right, 4 raised. That slash means or. All right, that's all it means. 4 raised to the 3rd power. And there's yet another way of saying this one, and it's 4 cubed. All right, so it's a special case just like 2 squared. The 3 is representing cubed. All right, so that's 4 cubed. And for now, those are the 2 special cases I know about when calling it. Is when it's raised to a power of 2, you say 2 squared, 4 squared, x squared, once the exponent is 2. Or once the exponent is 3, you can say 4 cubed, 5 cubed, x cubed, and so on. All right, so in general, that's how you call exponents if you have it written down, but you want to represent it. You want the individual to know what you have on paper, all right, or in your mind. So that's how you call it. And lastly, we look at the various representations. So there are 3 representations that we want to look at. All right, so we want to look at the 3 representations. And the first representation is going to be the index form. The index form. And all the index form is saying, as the word index indicates, as long as you see the base and the index is in the index form. For example, x to the 4th power. This is index form. So for the index form, you want to look for a base. And you also want to look for some exponent, power, or index. All right, same thing, different words, power or index. All right, and that's in the index form. Then we have the expanded form. All right, that's the expanded form. And as the word expanded suggests, for x to the fourth power, instead of having it as such, you'd have written it out. So you'd have x times x times x times x. And that's in expanded form. That's when you write out the number of times the base is being multiplied by the index. And lastly, we have the numerical form. If the base is a variable, we can't have a numerical form for it unless we know what the value of x in this case would be. All right, so for the numerical form, I'll have to use some form of number to represent what I'm saying. All right, so for example, I have 2 cubed. That's the index form. And then I'm going to write it in the expanded form, 2 times 2 times 2. And lastly, the numerical form, which would give me one number. And that's going to be 8. 2 times 2 is 4. 2 times 4 is 8. All right, so thank you very much for watching this video. That's just the introduction to indices. All you need to know about it, just beginning the basic idea. All right, so I'll be posting the videos on the different rules that govern indices. So there are some rules that you can apply. Once you see a certain set of conditions, you can go ahead and just apply the rules. All right, I hope you learned something, and I'll see you shortly. All right, bye-bye.